the simplest way to connect to an MCP server, whether it's running in memory, as a local script, or over HTTP, uses just one line of code. You'll see how FastMCP's client automatically detects the right transport for any server source, from a local Python file to a remote API endpoint, all with the same clean interface. From FastMCP Import Client, FastMCP. Hash examples of transport inference. Client memory equals client, FastMCP, test server. Client script equals client, /server pi. Client HTTP equals client, HTTPS//API, example, com/MCP. This demonstrates the transport abstraction pattern with automatic protocol inference. The design completely decouples the client interface from the underlying connection mechanism, allowing the same API to work seamlessly across in-memory, local processes, or remote HTTP servers. What makes this distinctive is its ability to infer the appropriate transport layer from just a string or object reference, eliminating manual configuration. The pattern works through a two-layer architecture where the client handles protocol operations while delegating connection specifics to transport adapters. When you instantiate a client with different source types, server instance, file path, or URL, the system automatically selects the matching transport implementation. This creates a uniform interface regardless of whether you're testing locally, running scripts, or connecting to cloud services. This approach solves the classic problem of environment-specific code, paths in distributed systems. Developers can write and test logic against an in-memory server, then deploy unchanged against production HTTP endpoints. The trade-off is a slight initialization overhead for transport detection, but the gain in portability and reduced boilerplate makes it ideal for multi-environment applications and testing workflows. Let's break it down line by line. From FastMCP Import Client, FastMCP imports the core client class for connecting to MCP servers and the FastMCP class for creating local tool servers. These are the two primary entry points for all FastMCP operations, whether connecting to remote servers or hosting your own tools. Hash examples of transport inference. Client memory equals client, FastMCP, test server. This demonstrates FastMCP's in-memory transport mode, creating a client that communicates directly with a local, FastMCP, server instance named test server. Ideal for testing and development, it eliminates network overhead by running everything in the same process. The pattern mirrors how you'd connect to a remote server, but with zero latency. Client script equals client, /server pi. This initializes a FastMCP client that automatically launches a local server script. The path, /server pi, triggers transport inference, detecting a Python script and handling process management, including startup, shutdown, and interprocess communication. Eliminates manual server management while maintaining a clean client interface. Client HTTP equals client, HTTPS//API, example, com/MCP. This initializes a FastMCP client over HTTP, connecting to a remote MCP server at the specified endpoint. The transport protocol is inferred from the URL scheme, enabling seamless integration with REST-based MCP implementations. This pattern allows distributed systems to expose tools via HTTP while maintaining the same client interface as local or in-memory servers. Transport abstraction pattern. FastMCP's client transport separation lets you connect to any server implementation, whether in memory, local scripts, or remote HTTP, using the same client interface, with transport inference handling the connection details automatically. The transport type determines whether your server runs as a subprocess, remote service, or in-process object. each with different isolation and overhead characteristics. This pattern eliminates transport-specific boilerplate while maintaining flexibility across deployment scenarios.
The client that knows no transport controls every transport